Hello class, welcome to lesson 5-6, which is about graphing inequalities in two variables. By the end of this lesson, you should be able to graph linear inequalities on the coordinate plane, and you should be able to solve inequalities by graphing. So there are a couple new vocab terms in this section. Boundary. A boundary is what divides the coordinate plane into two half planes. So for example, if I had my coordinate plane just like this, my boundary is going to be, if that is the graph of the line, that is my boundary line. So the line of the graph is the boundary. And then a closed half plane looks like what I've drawn in black. An open half plane would be, if this were the line, it would be dashed like that. Okay, and that'll make more sense in, actually no, I'll explain it right now. So you will have a dotted or an open half plane whenever you have an inequality that is just greater than or less than. You will have the closed half plane if it is greater than or equal to, less than or equal to. So just like with the filled in circles on the number line versus the open circles on the number line, this is how you differentiate in the graph. Alright, so let's start by looking at graphing 2y minus 4x is greater than 6. The way that you solve this problem, your first step, you want to solve for y. So if I solve for y, and I have 2y minus 4x is greater than 6, I have to get y by itself, so I'm going to say 2y is greater than 4x plus 6 because I'm going to add 4x to both sides. And then I want to get y by itself, so I have to divide both sides by 2. So I'm left with y is greater than, then 4x divided by 2 becomes 2x, plus 6 divided by 2 becomes 3. So now y is by itself. My second step is going to be graph, and it's going to be graphing, and you may be wondering how you graph an inequality. You start by graphing the line. You say y equals 2x plus 3. I give you the power to change that inequality symbol into an equal sign in order to graph your line. This is the only step that it's going to be an equal sign. Once we move on, it's going to go back to the original inequality, okay? So if we were to graph this line y equals 2x plus 3, that's slope-intercept form. So that means 2 is my slope, 3 is my intercept. So 3 is my y-intercept, that means it crosses the y-axis at 3, and my slope is 2. Slope is rise over run, so that means I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And I can also start at my intercept, and I could also go the other way. I can go down to left 1, down to left 1, down to left 1, until I have all these points. Alright, so I have the dots. I'm ready to move on to my next, actually, I look back and I say that y is greater than 2x plus 3. Since it is a greater than symbol, there's no or equal to. That means we're going to do a dotted line or a dashed line. Okay, so that's what my graph should look like so far. Then step 3, you are going to test a point. You may wonder what this means, but if you have already looked at your book at all, you're going to see that we're going to be shading part of the graph. So when I say test a point, I mean you are going to select a point. I generally choose 0, 0 because that is an easy point to do calculations with. So I say I have my y is greater than 2x plus 3. If I plug 0 in, it becomes 0 is greater than 2 times 0 plus 3, which then becomes 0 is greater than 3. Is that true? No. This is false. So if I look at my graph, I see 0, 0 is right here, and that was a false statement. So that means I'm not going to graph this side of the line. I'm going to graph the other side of the line. Okay? So your first step, you solve for y. Your second step, you graph the line, and if it's a greater than or less than sign, you do a dotted or dashed line. If it's greater than or equal to or less than or equal to, you're going to do a solid line. Step 3, you test a point. I generally do 0, 0 because it's an easy one to do calculations with. You can choose any number to test. That's fine. And then if you're still unsure, like, did I do that problem correctly, you can check your work. The way you check your answer, if I go back to my graph and I pick a point that's now shaded in, so for example, if I were to choose, let's say, -2, 1, -2, 1, that's in my green shaded area, so I'd say I'm going to check using -2, 1, just a point I just picked. My y is going to be 1, so I have 1 is greater than 2 times a -2 plus 3. So we have 1 is greater than, what's 2 times -2? That's -4 plus 3. And if I keep going, I have 1 is greater than, -4 plus 3 is a -1. Is 1 larger than -1? Yes, so we know that our answer is correct. Alright. Let's do another example. I want us to graph y minus 3x is less than 2. So first step, solve for y. So I have y minus 3x is less than 2. I'm going to add 3x to both sides in order to get y by itself. Y is by itself, so that means I can graph Remember, while we graph, we can change it to an equal sign momentarily. So if I were to graph this, y equals 3x plus 2, slope-intercept form again. So 3 is our slope, and 2 is our intercept. So 2, where it crosses the y-axis, and then 3 is our slope. I'm going to go up 3, right 1, up 3, right 1, and I can also go down 3, left 1, down 3, left 1. Down 3, left 1, down 3, left 1. Alright, and then I look again, and I bring back my inequality, and I just have a less than symbol. So is that going to be a dotted or dash line or solid line? It's going to be a dashed line. Now step 3. You need to test a point. Which one did I say is an easy one to test? 0, 0. So if we plug 0 into this equation, or inequality, we have 0 is less than 3 times 0 plus 2. So we have 0 is less than 0 plus 2, or that can just be written as 2. Is 0 less than 2? Yes, so I find 0, 0, that's a true statement. That means I'm going to graph everything on the same side as 0, 0. Or not graph, but shade. Everything on the same side as 0, 0. Alright. So let's look at another example. So example 3, we have graph x plus 4y is greater than or equal to 2. So if we start with step 1, solve for y, we have 4y, oh, we have x plus 4y. X plus 4y is greater than or equal to 2. So I'm going to subtract x from both sides. And then I want to get y by itself, so I'm going to divide everything by 4. So that becomes negative x minus, or negative x divided by 4, which is the same as negative 1/4 x, plus, what's 2 divided by 4? 1/2. Or 2 over 4, which reduces to 1/2. Now, let's work on graphing this equation, because that's our step 2. We're going to graph y equals negative 1/4 x plus 1/2. Again, it's in slope-intercept form, so I can start my y-intercept of 1/2. And my slope is negative 1/4, so I can go down 1 over 4. I can go down 1 over 4. Or I can go up 1, left 4. Up 1, left 4. And if we look at this problem, we have y is greater than or equal to, which means it's going to be a solid line. Alright. I'm going to recommend you be really careful about graphing and graph as best as you can, because otherwise you're going to get graphs that look wrong to you. Okay? So be very careful when you're graphing. Alright, step 3, we test a point. In this case, we have 0, 0. Alright, if I test 0, 0, that's right here, and I end up with 0 is greater than or equal to negative 1/4 times 0, which is the same as 0, plus 1/2. Is 0 greater than or equal to 1/2? No. So that means that I'm not going to graph on the side with 0, 0 because it was false. I'm going to, or not graph, shade. Sorry, I keep saying graph. I'm going to shade the other side. Alright, let's look at another problem. So if I show you this example 4, and I say graph x plus 2y is greater than or equal to 6, and I give you multiple choice, which two graphs can we eliminate right away just looking at them? We can eliminate letter C and letter D because they are both dashed lines, and we have an or equal to, so we know it has to be a solid line. Now, if we look at these two lines, they are identical. They both cross at y equals 3, and they both have a slope of negative 1/2, because we go up 1, left 2. We go up 1, left 2. So they have the same slope. So now what we need to do is, what if we test a point? We test a point, so just like I've been testing, let's test 0, 0. So if I plug 0 in for x, I have 0 plus 2 times 0 is greater than or equal to 6. So this becomes 0 is greater than or equal to 6. Is this true? No. So that means 0, 0 is false, so it should not be shaded. So which graph does not have 0, 0 shaded? Letter A. So that would be your answer. Alright, example 5. Alright, use a graph to solve 2x plus 3 is less than or equal to 7. This is slightly different than what we've been doing because we are missing what variable? We're missing our y. So that means we are going to solve for x in this instance. So I have 2x plus 3 is less than or equal to 7. So I have 2x is less than or equal to 4 if I subtract 3 from both sides. If I divide both sides by 2, I have x is less than or equal to 2. And I want to graph x equals 2. So it's still the same process, but instead of y, we're going to focus on x. So where does x equal to? X equals to here, 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 all around here. Right? This is all where x equals 2. Okay? But I have x is less than or equal to 2. So that means that it is going to be, is it going to be a solid or a dashed line? It's going to be solid because the same rules apply. And then for number 3, test a point. So if we test 0, 0 again, we get 2 times 0, because x equals 0, plus 3 is less than or equal to 7. So that just becomes 3 is less than or equal to 7. And that's true. So that means everything on the same side as 0, 0 is going to get shaded in. And that is how you would do that problem. All right, let's look at example 6. Ranjan writes and edits short articles for a local newspaper. It takes him about an hour to write an article and about a half hour to edit an article. If Ranjan works up to 8 hours per day, how many articles can he write and edit in one day? So if we look at this, let's write an inequality. So I'm going to say x is the number of articles he can write in a day, and they take him 1 hour. So that would be 1 times an article. So I can get rid of the 1 because we never have to write 1 in front of a variable. And then it takes a half hour to edit a paper. So x is the number he can write. Y is the number he can edit. Alright, and if Ranjan works up to 8 hours a day, we know we have an 8 here, what would up to be represented by? That would mean that his writing and editing would be less than or equal to 8 hours. Okay, so that would be our inequality. Okay. Then if we solve for y, just like we've been doing, we can say 1/2 y is less than or equal to negative x if I subtract x from both sides. Then I want to get y by itself, so I have a 1/2 times y. In order to get y by itself, I can multiply by 2, because if I multiply this by 2 over 1, I end up with just y. So then if I multiply this side by 2, I have y is less than or equal to negative 2x plus 16. Alright, and then if I were to graph that, I'm going to think about this graph. It's a story problem, and I'm told that he's working so many hours, and this is the number of complete articles. I only need the first quadrant because he can't work negative hours, which would be over here, and he doesn't care about incomplete articles, which would be down below. So I only need the first quadrant for this problem. So then I know y crosses at 16, and we have a slope of about 2. We know we are going up to 8 hours, or slope of negative 2. I know my graph's going to look like that because it's going to be a solid line because it's or equal to, and 16 articles is going to be max, 8 hours is going to be the max. So now, if I want to figure out where I'm shading, if I plug 0 in, is 0 less than or equal to 16? Yes, so that means I'm going to shade everything underneath this line. And that is how you would solve that problem. Alright, if you have any questions, please feel free to email me, and I hope you guys have a good day.